Hello, everybody. So, on to week 2 of an 8-week class. These do go quickly. Um, got a couple of little odds and ends that were uh, on the list last week, or one that was a question was asked, and I should have put it on the list last week. We kind of ran short on time. Then the next couple things to look at are arrays, which are actual arrays this time. Way back in your SDEV 120 class, you probably learned the definition of array and then use list in that class, which are easier to work with. Arrays are going to be much faster, much better for the computer. So if the situation calls for an array, you get a lot. It's better to include them in your program. And since we have actual arrays, we'll also look at lists because again, they're easier to work with. And built into Java are ways to convert between arrays and lists. So we get the benefits of arrays at the times we need them, but we can do most of our coding with lists, which is easier to work with. Then we're going to kind of look at methods, and what the textbook does is they spend a long time dealing with static methods. So we'll probably do a quick example that has a static method, and then move to non-static. Actually, would have skipped the one example, except I'll throw the error message from it, so that you can see what to do if you encounter that particular message. Question was asked about bug reports on the homework assignments. I kind of lately, and I forgot it was in the homework here. My class. Actually, I'm in like every program class. It's just sort of two reasons. One, practice for the field. When you're working as a software developer, and needs to be documented. So when there's a bug, you have to properly document that a bug exists, and then fix it, and then add to the documentation what you did to fix it, what you did to replicate the bug, and what you did to fix it, and confirm that it works, and all that stuff. It's also good for education purposes. That 3-step learning process, you all have probably heard that before, right? Speech teachers usually make a big deal about that, right? Preview what you're going to learn, actually study, actually learn the material, and then review it one last time. So I like the bug reports for that extra little review step at the end. It doesn't have to be anything fancy. If you want to, a number of people have done this over the years. You can go do a Google search for bug report template or something like that, and just fill out the template. Some people have done that just to get some practice of what it would be like after graduating and actually working in the field. But anything will work. You can just do a text file with just a few notes, like a bulleted list of them, or even something in the comments. Please include that. It is part of the grade on there. There'll be point penalties if it's missing. So even if if you don't encounter any issues, right? If you sit down and the code works on the first try, then put in the bug report, no issues encountered, worked on the first try, or some sort of note about that. But in general, just list out what bugs you encounter, right? Made a typo in the print statement, and then the resolution to that bug is fix the typo. A little list like that. It doesn't have to be too fancy. Put it in the comments in the script will probably be sufficient at some times. Hey, Gabriel. I was just talking about the bug report. It's in the homework assignment. Please include those, just something brief, a little summary of what went wrong and what you did to fix it. Or if there's no bug report, just write like no bugs. When you make the program, just say no bugs encountered. Shouldn't be any problem there. A couple other things that I had on the list last week that we kind of ran out of time for. One of them is going to be board notes. So we did have time to kind of look briefly at our math operations. Nothing fancy there for those who have seen programming before. Integer division versus floating point division is just based on whether you pass in any sort of floating point number, a double or a float. So if we had, we'd probably store them in variables, like 3 divided by 5 would be, let me do one easier that everyone probably knows. Instead of 0.6, 3/4, most people know that off the top of their head because that's a common money one. 3 divided by 4, those are both integers. 2 integers going in gives us an integer coming out. So that would be 0. And then we do 3 mod 4 to get the remainder. In order to do floating point division, we just add 0.0 to either number. So 3.0 divided by 4, there's a double in an integer now. So that would give us the 0.75 that you're familiar with. Or we saw casting. We want to turn it into double types. We could put 3 cast into a double type divided by 4, and that would give us the floating point. Again, so as long as at least one of the numbers is a floating point number, has a decimal in it, you'll get back a decimal. That was like, I think that was skipped over. Most of the other math is fairly straightforward. Oh, were you writing that down? Oh, I can leave that up there. There's plenty of room on the board. I don't need to erase that. This is probably the cleanest way to do it. Because usually 3 would be stored in a variable. So we can't just add 0.0 on a variable. So we cast it into a double and then divide. Other one, order of operations. And one of the homework questions, I did choose this because you're going to use parentheses in your conditions. You're going to, the way most people would logically put it together, the order of operations is going to fail. So does everybody remember in math class, PEMDAS? The order we perform our operations in. That's not actually an accurate label. Probably heard some random words, usually funny and especially inappropriate things are easier for humans to remember. So there's lots of acronyms. You can Google funny ones that are way better to memorize than what your math teacher told you. But parentheses, exponents, multiplication, division, addition, and subtraction. But that's not the best way to put it. That doesn't translate to other things very well. Parentheses usually refers to grouping. Some sort of grouping operation. Not just parentheses in math class, we often use square brackets and curly braces. Fraction bars group things. A square root symbol, everything under that square root is grouped together. So anything that is grouped together, we do first. Just when we learn it, it's usually way before we get to that other stuff. Exponents as well, those should show up earlier. What it is unitary operations. Which most of our operations are binary, right? 2 numbers. In order to add, we have to have 2 numbers to add. But if we're going to square a number, all we need to know is the number that's being squared. So there's actually only one number there. That one's kind of a confusing example because we represent the operation with a little bitty 2. So it looks like a second number, but it's not a number. It's the operation. But any of our operations that only take one number. Factorials, exponents, and functions. If there's like a cosine or a sine, those who've seen trigonometry, cosine or a sine work into the middle of a big long expression, we would find the result of that function before adding and subtracting to the things around it. But things that only take in one number. Then our other one, this is our binary operations. And when we learn it, we learn multiply and divide, going left to right. Add and subtract going left to right, but at some point along the way through school, you've probably heard division is multiplied by the reciprocal. So division and multiplication are actually the same thing to a human. To a machine, we might look at what it takes in a machine. So like usually multiplication will be 3 or 4 steps of assembly language, whereas division will be like 70 or 80 with the same numbers. Division's really hard for machines. But they're really the same operations. So then we do our binary operations. I'm going to use the word proximity here. By how much they affect each other. Like multiplying and dividing the numbers affect each other more than adding and subtracting, right? So it's like they're closer. It's also a logic thing. Have y'all heard the phrase multiply and add or? That's consistent all the way across mathematics, from like what you learn in math in kindergarten up to 600 level graduate studies math. We multiply ands and add ors. Some people hear it in elementary school and some people don't hear it till, I remember sitting in like a calculus 2 class and somebody said that and people were surprised. So all of us hear it at different levels, or maybe some people just don't pay attention when they first hear it in elementary school or something. But and is the inclusive operation. It relates to multiplying. Or so it's closer to multiplication. The reason I was going over all of this is because with our logical operators, they follow the same pattern. Am I still on the board here? Oh, on screen, yeah. So with our logical operators, we have the same order of operations because we are doing something mathematical. First thing we do is any grouping. Just like this. Then we do the unitary operations. Then we do the binary operation. Starting with the proximity thing. That just seemed like a word that made sense. Or that multiply ands and add ors continues right there. We multiply and, that means and comes first in our order of operations.
I have a question.
Yes.
If you have multiple sets of grouping in your code, would you need to specify which group to solve first, or would it just automatically just start from left to right?
Left to right. Left to right will always work. It's sometimes right to left doesn't work. So instead of stopping and thinking about whether or not we're in a situation where right to left doesn't work, like subtraction, will sometimes work if we go right to left, but not always. But left to right always works. So just if you always go left, the computers that's coded in there. Always go left to right as it's written in the text file. Okay. Which does follow left to right. So just like in our math class, going left to right with the groupings, unitary operations, and then binary operations, which that's going to be the parentheses when we write code, because square brackets and curly braces definitely mean something different in Java. So our only option for grouping is parentheses. Then we'll have our not, because not only takes one thing, right? If we have a 1, not 1 is 0, and not 0 is 1. So we only need, that's our unitary operation as far as logic. And then the binary ones, we do the and first, then we do the ors, left to right. And one of the homework questions I assigned this week, if you're not careful with the groupings, the way most people would put it together, the order of operations is going to get thrown off on the and and the or. That's part of the reason I really like that question. Order of operations. And another thing about the floating point numbers, so like over here. I wrote 0.75 there on that one, but that's not actually what's going on in the computer. I didn't put a little F here. If I put a little F here, we'd have a floating point, a float type instead of double type, as we get back what we put into it. But with a double, it's a 64-bit number. 0.75 is not a 64-bit number. So we have 0.75, 0.0000000 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. Then something else. In this particular case, we probably have a 3 there. We probably get that, which I'm just going to switch that back to an X. There's specific patterns to how it happens, but I'm writing this in decimal numbers. I remember converting back and forth between binary and decimal numbers in your SDEV 120 class. Do you have to do that with any floating point numbers? It's okay if I erase the order of operations. The big one is just remember and comes before ors. They're not equally weighted. The other two are kind of obvious.
Whenever I was in 6th grade math, we were working on dividing decimals, and I would always get marked on my paper because it would be like 0.75, and I would put 0.750 because in my mind I needed to know that like there was a placeholder at the end of it, and I always got it marked wrong, and it was a big thing because my dad was like, "It's the same thing. It's just a 0."
So there is a technicality in the metric system that is not, because 0 implies that it's rounded.
Yes, that is. Yes.
If you have 0.75, that means you have exactly 0.75. But this number would actually be 0.750, implying that it's not perfectly 0.75. You just round it or you locate it somewhere. Do 3 digits, that's enough. Over to 4. This is probably enough to show the point. So the integer side, y'all have probably had a little bit of practice with that now, right? It should have first shown up a couple classes ago. So 0, 0, 0, 1, that's really easy one. But 0.07 looks really nice in base 10 in decimal numbers. But when we go to binary, we have to add up a bunch of columns to get there. So 1/2, way too big for 1/7. Actually, I probably need more than 1. 1/4, way too big. 1/8 is 0.125, still too big. So next is 1/16, 0.0625. 0.0625 will work. So we have one of those. Minus 0.0625. And we subtract that. What do we have left? 0.0075. We have something left over though, right? Already up to a couple more digits, and I chose this number. This one does not work out within 64 bits. If you want to carry that on and keep doing powers of 2 and see what it comes out to, for a 64-bit double precision floating point number, 1.07 does not come out either. We run out of bits before we get that perfectly worked out. So that's part of what this is about. It's also electrical fluctuations. Little things can happen, little glitches in there. Depending on how heavily we're using the machine, different little things can happen. That one's not as common as it used to be, but it's still prevalent there, especially if we're dividing. We get a larger result than if we added or multiplied, because there's more steps, so the CPU is going to get hotter, and there's going to be more just random electricity in there that might not dissipate in time. The little things can happen somewhere in there. Most of our languages, that gets cut off. In most programming languages, they say, okay, it's going to be a long way before that gets cut off. We'll tell the CPU it's a 64-bit number, but we're only going to use 60 of those bits. So that last little bit there that's a little off just gets cut off. But in Java, they go with as much precision as possible. So we use all 64 of those bits. And some of them way over at the end might be a little off. The end result of this, we have something there. I wrote it with the X. We don't know for certain exactly what's going to be there in every situation. I wrote a 3 there because I've done that one a few times, and it's consistently a 3 way over there in that place, but they might not perfectly align, especially if one of them comes from dividing, another one comes from adding, or maybe another one comes from explicit input from a user. The point of this is don't check equality on double and float. So don't do equal in your conditions. Greater than, less than. Actually, you could include the or equal, but you can't count on that or equal to part, because that little extra little bit where we're looking for maximum precision might be a little bit off. So if you say less than or equal to 0.75 and it ends up being 0.749999999, that condition might not end up. I'm going to say greater than. You say greater than or equal to 0.75, but you get 0.7499999999. It would miss the condition at a time that it should. So just don't use equality on a double or a float. There are other ways around, usually greater than, less than. If you have to, which you probably want to manually do it, is greater than, less than, and equal. We get those from subtraction. Right? If we subtract 2 numbers and our answer is positive, then that means the first number was bigger. So there's the greater than. If we subtract and get exactly 0, then that means they're the same number. And if we subtract and get a smaller number, that means the second, or a negative number, that means the second one was bigger. So you could, if you absolutely need equality, it'd probably be best just to subtract the 2 numbers and see if you're within a certain threshold. You know, it's going to be at least like 14 places over past the decimal. It's going to be way over there. So you can set a fairly small threshold, kind of like most of our other programming languages do, just by truncating that off somewhere before we get to that wiggle room at the end. But Java doesn't. Java leaves the wiggle room in there. So just be careful when checking equality between two floating point numbers. Which is there is several questions in the quiz bank about that. The quiz bank for this class is huge. I will double check all the quizzes and put points back on it because there are some errors in there. It's way too many questions to dig through and double check all of them. So I just put the points back on when I double check it. So there might be some little issues. After everybody takes it, I'll do that. But there's quite a few that would have that difference. So it asks you some question. It'll ask you some question that gives a floating point number. And one of the options will be like 0.5. But 0.5 isn't really isn't the best answer because 0.5, 0, 0, 0, 0, 0, 0. We would have 14 zeros and then another number on 0.5. So like the random function wouldn't really give 0.5. Watch for that. There's a bunch of questions in the quiz bank about that. So there's a good chance you'll end up with seeing one of those questions. Okay, so a couple small things from last week. That one can make a big difference in your coding there because we're constantly comparing things, right? That's something we do all the time when we code. But some more on syntax. So arrays. I'll write up a definition here. Similar type data stored the recursive algorithm. So this is that definition where in your introductory classes, you probably always work with lists. I think everybody's using Python in those classes these days. Or in Raptor, that's actually Perl, which is also a dynamically typed language. Just we use pictures to type the Perl code in that particular case. So similar type to fill that definition every time immediately in Python. But in Java, we do have specific types. And the reason that strictly typed languages are nice is it's faster. The computer doesn't have to take time to figure out what we have. The computer doesn't have to pause to figure out if we have an integer or a string or a floating point number or Boolean. We told the computer what type of data we have beforehand. So there's never a waste of figuring out what it is, and our resources can be used more efficiently because we already know what it is. If we say we have a byte, the computer's going to give us 8 bits for that and never have to worry about whether it needs more or less or anything like that. So this diagram here. So stack and heap diagram. I'll color code it. I can put the list on the same one. Does anybody have any trouble seeing colors? I'm already writing in blue. That's the worst one. Any markers I need to throw away? I just have red, green, and blue. I see head shaking no. Okay. I don't know if that's like, because that color blindness is a health issue. So I hope that doesn't fall under HIPAA laws, but I feel like I should ask that so I don't end up writing in the color somebody can't see. I've heard blue is the worst. I've heard for people that can't see blue, I might as well be writing with a white marker.
Yeah.
So here in our diagram, we're gonna say over in our code somewhere, the stack side, we're gonna say we have an array. And it's gonna put together a recursive algorithm. I'm gonna write a slightly start plus index times size. Yeah, actually, that's the actual one. I was going to write something, add some multiplying in there, make it a little bit fancier. Here's the actual algorithm I'll use. The next one is at the start position plus the index times the size. So it uses +1. Back in the early days of computers, when we had vacuum tubes and the house size radiators, turning on a whole bunch of bits right next to each other when they were actually heating coils like we have in a toaster, that was a big fire risk. So we would scatter things around. So our algorithm might look something like start plus 4 times index, or 4 times size, plus 243 or something, that would scatter it around so it doesn't even fall nicely in a grid pattern. Something fancy, and then once we get that one, we just find the first one, then we take the next one and we plug it back in, and the recursive means we're plugging the answer of the previous one into the next one. So we get the first one, then plug that back in to get the start point for our next index, and so on and so forth. But we just keep using this algorithm over and over again. So the computer is going to randomly choose a start size. So maybe it's going to look something like this. So I'll say byte. We have a bunch of byte data. That way it's easy to draw on the board, 8 bits each. Call it ARR. And then we'll add square brackets. We'll see the syntax in a minute. There's going to be a new array of bytes. We'll see it in the example here in actually less than 5 minutes. We should draw the picture. So it's going to choose some starting point. Maybe it's going to start at bit 240. That was a spot where the computer had open. One thing we do have to say is these are not dynamic. So we have to say how big it is. In Java, we put a number right here. And these square brackets, we might say 4. And that is fixed. That cannot change. If we realize later that we needed 5 elements for the array, our only option is to make a new array that holds 5 elements, copy everything over, and delete the original. It's all fixed, but that translates to speed directly. Things run faster when we take that sort of control. So we have 4 things. So we have our 8 bits here. Start plus index plus size. So we started at 240 plus whatever index we're on times our size, which is 8 bits. This is why we start at 0. Indexing starts at 0. Everybody's seen that before. Ask for the beginning and count from the end. Because when we ask for it, we need to go to the start point plus 0 bits. But we don't actually have our data until we get 8 bits in. We start ask for the beginning of the data, but we don't count until we get to the end of it. That way that's what leads to that discrepancy between the index and the length of the array. I think everybody's seen that before, but we'll see an example here in a moment. Then when we get to the end, I'm going to add something to this, plus 300. That way the picture spreads out a little. So sort of like the earlier algorithms, I'll just add 300. So we started at bit 40. This is index 0, our first one. So 240 plus 0, we have our starting point. Then the first one, 240 plus 1 times 8 plus 300. So our next one goes to 5. Somewhere else in RAM, we have bit 548. We have our second piece of data there. And there's no connection between those two except for that algorithm that the computer knows. Except the computer can calculate where to find the next one. And so on and so forth. So like 240, 2 times 8, so plus 16, plus 300. What is that? 256, 300.
556.
That's what we do close. Oh, I meant to do a times there, yes. So that would be right here at the next one, 556. I guess that'll work. Does that algorithm make sense? I meant to do times there, that way it spreads out instead of just going right next to it, but I wrote plus. This is how it actually does it, because on transistors, there's no longer a fire risk like there was in 1955. So we just use the next spot over. And the computer can quickly see it's like, okay, 4 bytes means you need 32 bits. So it's going to set aside 32 bits for us right at the beginning. And then jump between them. Just wherever they're located, there's no connecting point between. That'll be important when we talk about what a list is in a moment. Oh, something in the chat room. Oh, no problem. I should write your name on the list, though. I'll let you into the Zoom call and then write your name down. I do keep track of that. Which I can't remember if I said it or not. If you'll notice, I am on my own personal laptop here, and the Zoom call is running off the computer in the classroom. So if you want to send direct messages for some reason or another, instead of just putting it in the chat room where everybody can see it, make sure you send it to my laptop. They usually say Chris, and then whichever one it is. Like today, it's on the PC, or also Chris Mac or Chris DB. I have the Chromebook out, or whichever machine I have on a particular day. Make sure you send any direct messages to that one, because I might not see them on the classroom. Pop in on the classroom computer. So that's the basic idea of arrays. Fixed. I'll write that really, really big. Arrays are fixed size. So just remember, we can't change the array. If you make one with 4 elements, then later find you need to hold 4 element or 5 elements. Your only option is to make a new array and copy everything over. A new array that holds more stuff and copy it over there. Let's look at the syntax for that. And the trade-off for that is faster and not like subtly faster. Like, I don't know, we'll probably measure things in milliseconds. So you're going to get 3 or 4 digits of faster off an array versus a list. You're in the hundreds of milliseconds faster, which doesn't take very long to get up to big stuff. And remember, Java is mostly used for big things anymore. Think of Human. They're a good example. I looked it up. There's about 60,000 employees. I took a guess last week. 60,000 employees and over 10 million customers. Okay. Those are huge, huge data sets. We don't see stuff like that in the classroom. So when we say a little bit faster, we mean a little bit faster for every data point in that set. So if we've got 60,000 customers that all dealing with millions of customers, that milliseconds faster adds up significantly very quickly at enterprise scale. Let's see, Zoom buttons are just all kinds of in the way here.
They always are.
Yeah. And maybe that'll be better. So I'm gonna do a new project. Maybe I haven't done a Maven project yet, so I'm gonna create a new Maven project. Mostly I'm gonna do stuff with Ant and they're not gonna be digging through the folders, but maybe we'll look at some of them. Maven was made by the same people that made Ant a few years later. Package management stuff. Probably have to install all this stuff. Maven is centralized, so it's better for like spinning hard disk, and Gradle is distributed. Otherwise, they're very similar. And the distributed system is going to be better for solid state drives, so SSDs. So most stuff on Java is going to be done for enterprise scale these days, which means it'll be running on a server. And most servers still use solid state or still use the spinning disk. So most stuff in Java would probably be done on Maven. I'll just call it Maven project. Oh, I meant to point out the group ID. Notice the group ID. So I'll pull it up in the POM file. Notice the package name. When it created folders, it used this. It asked for a group ID. And it started with something that com.mycompany. Hopefully it reminds you of a website. The package names have to be unique. They have to be globally unique for every Java programmer, not just your own stuff. So one good way to do that, what they came up with early, is websites also have to be unique. So if we just turn our website around, mycompany.com is a generic one, but like my general one I use is CS Francis 555. That's the one I pay for every year. Put up websites and they usually expire. I forget about them. 6 months later, realize they expired and the host already deleted all my files and stuff. But I do on my list of bills to pay that once a year for that domain name is the one I keep paying for. So for a common package that I know will be unique, I can use com.csfrancis555 because nobody else in the world would have turned their website around and get that same thing. And then we get into the naming thing like all packages. Let me get these out of here. You'll notice the Java code looks about the same. With the centralization, I'll look at the build file still. The build file is all in one place. All of our build instructions are in one place, done as XML. This gets very large. If we need something else, like what's something we'll mess this up? Come up here and right click here on dependencies. Got the build version. Where's that? let me build this. Usually I have a button there. Maybe I need to build it first. But there's all of our build instructions, which hasn't been built yet. So like a version number, packages as a jar file. Version of the template, that's the template we're using. There's that group ID and a bunch of XML code. We will often see XML in Java. JSON has become more popular. But the reason for that is JSON is better for dynamically typed languages. And in the modern world, we're probably going to be doing stuff most often with JavaScript and Python, which are both dynamically typed. XML is better for strictly typed languages. So with a strictly typed language, it's better to use XML. We'll see that more when we get to Beans on Thursday. But we will see XML used quite heavily in Java as well. Plus, there's probably some tradition things there. Quite a few things that might be better in JSON these days that have been done in XML since long before JSON existed in Java. So there's some of that as well. But in general, markup languages are both strictly typed languages. Our source files are a little bit different. They don't look bad here in the IDE, but the IDE knows what all of those are. So see all those dots in that package name? That's actually a file path. When we write it in code, we use a dot, and when we write it instead of a slash, like file path. So if I come over here to the File Explorer, yeah, that's just a file path in the code syntax instead of the File Explorer syntax. We're going to create that nipping stuff. Oh, there it is. Chris Ward just looked in that folder and it wasn't there. There's that project, and then our build file, and there's only one of them. Everything is consolidated in that one build file. And as we add more stuff to it, it just adds to that one file. A good summary of the difference between Java or between Maven and Gradle is Maven would have one file with 1,000 lines for the build instructions, and Gradle would have 1,000 files with one line each to carry out the same activities. One of those is much better on the traditional spinning hard disk drives, physical hardware, and the other one's much better for SSD drives. So if we go in here in that project, there's a folder called main, and that's something called Java, and com, and my company, Maven project, and a whole bunch of folders. You see that file path there to get down to it. It's just, we use the dot if we need a file path in our code. But a whole bunch of folders, and then there's one file in there. That's actually much better for the computer. We'll talk about hash tables before long, and having lots and lots of folders with very few things in each particular one is way better for the computer. When we get to hash tables, we can talk about why it's better for the computer, but that's still a couple weeks away. So a different organization scheme, all of the build instructions are there for us. This came with the default print hello world. So when I hit run, one thing you'll notice, that AMP project like we were doing the other day probably would have already finished by now. And right now this is going out, and it had to take a long time because I had to go out to the internet and check the central repository that Apache runs to make sure it was up to date on everything. Well, and it took a lot longer to do that build. I have the right click now. Oh, right click not working. But I should be able to right click and add things to this dependency. We will see that before long. I'll have to dig around and figure out why that's not working right now. Could be my keyboard getting a little old. So we need an array. So I guess a good common example would be an array of integers. We have like 5 integers we want to store. So it's going to be int type of data. Actually, we've already seen the syntax for array, right? Right over here there's an array called of strings that we're going to call args. We should do something with that. Int. So we have our type, and then square brackets and some sort of reference name to it. Array of integers equals a new int, and then square brackets over here. And you'll notice it's still underlined because everything about arrays are fixed, non-dynamic. We have to say how big it is. So if we want 5 things, we have to explicitly say we want 5 integers. Then there's syntax that's going to look very familiar from other languages you will have worked with. So index number 0 is a column of 4. Let me just copy and paste that line. Paste, 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 paste. Make another point. Things like that show up a lot when we're writing code, right? We have a bunch of lines that are very similar. It can actually be more productive to work down our columns than across. So if you know how many times it's going to happen if you copy and paste, this is a really short line, but we have to change our mindset a couple times. So we're going across, we have to, if we go in normal order, we're going across, we have to think about what index we want. Then we have to think about what number goes in that index. Then we have to change our frame of mind back and think about the index. And then think about the number we want to put there. And then back and forth, index, what number do we want to put there, what index do we want, and we're switching our mindset back and forth. But if we work down the columns, it'll work this time, so 0. We can just go down, think about indexes, do all of the indexes at once, go down the column, and then we come over and go down and put the integers in there. So like 4, 2, 18, 347, 1. That's a bunch of integers. Hopefully that second part, the syntax, all looks familiar. Going down columns, depending on how complicated they are, that can also work better going right to left as well. Because if we change things on the left, the stuff afterwards is going to get out of line, right? If we go from 1 digit to 2, but if we change things on the right, the stuff to the left of it's not going to change. So breaking out of those patterns, right? You're used to working left to right, top to the bottom because of English, but we're not writing in English. So breaking out of that pattern can be quite productive at times. I'm just going to, then we would typically do it as a loop. We saw the basic for loop the other day for it. I equals 0. I is less than, we need the size. So I'm going to say array of integers dot length. And that is a variable. Let's make a typo there. Yes, I did. Yeah. I'm going to copy that and paste that in. Okay, that'll fix the typo. Notice the length is a variable. That actually breaks away from our Java conventions when we get to object-oriented stuff. We might get there tonight, will probably be Thursday. Because lists are going to go pretty quick. And be Thursday when we get into object-oriented stuff. And one of the Java conventions we're going to see is that we always want to protect our data. We want to encapsulate our data, which means make it private so that our data fields aren't directly accessible from the outside. But this is like that thing we saw the other day where power is such a common thing that was added to the language before they realized they needed to clean up C++. So this one breaks from the conventions, and we do access that direct. We do access the length of it directly. Then I plus plus, probably no surprises there. And then I'll just print out whatever it is. I is holding a plus array of integers index I. Everybody's seen that syntax before, right? You were in probably worked in languages that did not technically have arrays, but as far as syntax goes, it's exactly like you're used to. What we often call an array in Java, even or in Python, even though it's not. But it's an actual array this time, so probably no surprises here. Run this, we'll see those print statements. It's a Maven project, so it takes a minute to build, and there's a bunch of other information. But if we scroll around, we can find that other information that saying what's in there. Oh, I guess I'll just revert to Python again. So starting in Python, you also saw a different way we could loop through a collection, right? The for loops in Python are what we call for each loops everywhere else. And in Java, the for each loops are more efficient. They're better than setting up an integer, right? Just to store this integer here, that's integer I equals 0. That's a 64-bit integer, or sorry, that's a 32-bit integer. So we're wasting 32 bits there just to look at this whole collection at once. And we don't necessarily need to identify any of them. Like in this case, we're just printing them all out. So if we're going to walk through the whole thing, we also have a for each loop. Another great syntax. Oh yeah, I was thinking another language. It is just for. For each is, we'll see for each in a few minutes after a break. So also a for, but instead of this counter index, well, this one might not be the best example because it's still an int, but we'll say int. I'll do E for element, colon, then array of integers. So in this case, I probably could have started with a double or something, so it doesn't trivial. But in this case, int refers to the type in our array. So for each integer, we'll call it E in our array. Same thing. We don't have that index, so I have to change the sentence. Next up is a plus whatever that next element is. Maybe print a couple line breaks in here, spread those out. Make it a little easier to read. So you can see basically from our end, it looks about the same when it comes out. It's a little bit cleaner in the code. You don't have extra data to keep track of, extra counters. If you need a particular element, you'd have to add in a condition to test things to see when you get to that element. But it's generally more efficient if we're going to walk through our whole list. Another way we can do it, I'll do it with doubles this time. Double numbers. Sounds like a good name. And I want that to be an array equals, and an alternative syntax is in curly braces. We can put out a comma separated list of everything. There is a restriction on this one. I remember last week we were doing some things where we would like declare it, and then later is where we would assign it, which we could do up here. Something like this. I'll copy this line and paste that down here and then erase it. So we split up our declaration and our definition. We all encountered those terms before. We declare that we have an array of integers, but then it's later when we actually define what that array of integers is. If we do it, use this syntax with some curly braces and a comma separated list, we cannot do that if we split up our declaration and definition. That can only happen on the same line. So I'll split declaration and definition here. Then we could just put some integers in there, 3.14, 2.82, 1.61. That's a good list. And then the regular for loops, we saw those before, or this a little bit clearer since that end seemed a little bit different. This time our array has doubles. Oops, if I can type correctly. Or double numbers in public numbers. Random stuff. I guess the words aren't the important part here for each loop. Does that make sense? Seems straightforward. So quick head nods here. Over later. The next one will be a little more interesting. So that's our strict arrays. We can do it with any type of thing. Oh, string args. You might want to see what string args is, because we didn't see that last week. So we have this array. I'll put it up here at the top. Probably want to check and make sure that args is bigger than 0. So if args.length is greater than 0, then for each string, I'll call it S in args. We'll print out that string. S was passed into args. So if we run it here, it's not going to do anything. This time it's just going to skip right over that particular print statement because, well, we haven't set that up yet. We'll see how to set that up in just a second. I'm going to come over to where that's added File Explorer. Yeah, it's Maven project, isn't it? So I'm going to dig through all these folders. Oh, notice target. When we looked here a minute ago, there wasn't. So our build stuff goes in here. Here's our classes. Way down here is Maven project.class. And target generated. Yeah, our source code. Yeah, that's where we build stuff at. So when we get to the end and finalize our project, I'm going to go in here. I'll have to delete this in a moment. Right down here to where this is at, and then I'll go. So have the Java compiler build that Maven project1.java file. And then run that here. Maven project1. I already realized I was going to do that. Yeah, it's a Maven project. It's not going to like that. Let me do a really quick example over here. And do it here. I could do it in Sublime, couldn't I? So I'm going to open the text editor with testing.java. Sounds like a good name for it. I'm gonna take this class quick. Y'all have seen this syntax before. So public class has to match the name, testing, which this always has to be there. Public class match the file name. So on Java 21, which actually the first release of the long-term support candidate came out last Friday. So Java 21 is out. They're collecting any information about bugs they find, and then it's supposed to enter long-term support on September 24th. And at that point, the compiler will type all of this for us because it always has to be there. So there's no human thing. Likewise, our main method has to be static. It has to be void because there's nothing to send it back to. It has to be static because there's no classes that exist here that we can pull the method from. Main string args and passing in string args will be optional. I'm going to copy over that thing that I did over here. If args is greater than 0, then print out whatever it was. So nothing too fancy there, but when we compile and run this, so Java C testing Java testing, and notice nothing happened. Our condition failed. We didn't pass in any arguments to fill those parameters or that parameter of an array of strings. But we could. And make that a little bit bigger so that it's not all small in the prompt there. So if we say Java testing 1, 2, 3, and notice there's space delimited. So kind of like scanner, we looked at that briefly last time. It knows a lot of our common delimiters. And notice that 1, 2, and 3 are separated by a common symbol that humans use to separate things. And this time so we just space delimit a bunch of options, and those go in as parameters. So that can be important for things like usernames. What's the username that the software is starting up on? What was the last file open? Because some software we always open to the last file. Accounting software is really big like that because why would we have a different set of accounting books, right? If you had more than one accounting file for your company, the SEC would get very, very upset and go through every single line in there to see if there was any differences. We wouldn't need 2 sets of files for those. So the most recent file open, that would be a common thing to pass in there. Then we can access it, but just pass in a space delimited line when you run it, which our IDEs can also do that. Does that make sense? Any questions? I see head nods here.
Yes.
So over here, all right. Oh, there it is. I guess it didn't fully build. Now my right click works. I'll get to that in a second. So if I come up to the project and right click on Maven and come down all the way down to properties, there's a bunch of things about it here. The properties menu in your IDE, whether it's NetBeans or IDEA or Eclipse or whichever one you're using, the properties menu will change based off your package manager. So we're in Maven, so we see a different properties menu than we would in Ant, or a different properties menu than we would in Gradle. So that definitely takes some getting used to. So general gives us some information about it, can do a summary of it, description, our source stuff, build when we compile it, what happens. For arguments, hopefully, probably narrow down pretty quickly that we need the run command. And notice that we'll all have run, the instructions for what we run. Default config. Notice I just built it somewhere else. Maven took notice that I'm trying to build it in another file, and it has no idea what's going on now. So if I hit run right now, it would say it doesn't know what the main class is. And then here's a box for arguments. Let's come back to this. Let's see that error message. This was working a minute ago. Oh, no, it did work. It fixed it. Did it fill in that box? Please. Oh, it didn't fill in the box, but if we hit browse, we only have one file here, so we only have one option. You might hit that occasionally. Your IDE will say you can't figure out where the main class is. Last week, and then again tonight, all of our examples were just generated from that. So we were just, it obviously knew where that was, but if it doesn't know, or if you uncheck that box and say you're gonna create your own main class, you might want to make sure and hit that, go fill in that box. And then I'm doing some do 1, 2, I'll do 3 that way. Same, something similar. And zoom button very much. I can't hit okay, there we go. Hit okay. And now when we run it, it's going to pass in those arguments. So that's how we get those if we need them. Most common uses for that are probably going to be username, what user is accessing it, or most recent file open. Having the most recent file open, that way it can just jump back to the part you were at previously. I assume everybody has seen software do that before, right? There's the basic syntax of arrays. Syntactically in the text file, it's going to look a lot like what you're used to. Having seen Python before, I believe everybody said yes when I asked that question first day. So I'll continue to back to that, except it's strictly type. So remember, you have to say your type, and then those square brackets to say it's an array go with the type. But we've been doing that since day one because of the string args, the array of string called args that's just in the main method. Give it the name. If you want to use this syntax, you cannot split up the declaration and definition. That has to be done on the same line. That you declare you have it. Otherwise, make sure you remember to use the word new and the size. So slightly different syntax, but in general, working with them is going to look exactly like it does in every other programming language because that was standardized long before 1990, early 1990s when Java was created. That pretty much square brackets for arrays have been standardized way before Java. So that part will look familiar. And then if we have numbers, we can do math with them. It's just, then we just treat it like a variable name. Doing things, I do want to do one quick thing here. So notice we have our dependencies. Let me open them. So something about the build file. So here's the build instructions. If we wanted something else, like I'm going to go to dependencies, and maybe for some reason, I wanted to add a Jasper Tomcat embed. I think that'll find it. There's one centralized repository. Well, maybe that can't find it. Jasper. Tomcat. Okay, I don't know why it's going so slow. There we go. So if I look for Jasper embedded, okay, find it. I mostly just wanted to point at this. Where's it not searching? It usually goes way quicker than this. I'll do this too. It's one central repository. Maven projects have one central repository where everything's kept. Tomcat, I think that's the name of it. So if I search that here, notice the Maven repository is right at the top. A lot of people like to do this. So if we go there, tells us a bunch of information about it. I'll just grab the newest version, and it gives us this XML code right here. We would just copy and paste this into our POM file to tell the Maven project to go download this file from the central repository when we need it. Which our IDE should also be able to do, but it can't seem to search right now. Oh, Jasper's not in there, that's why. Let me try this. Org.apache. Tomcat.embed. Okay, I don't know why this isn't searching for it. It's usually really, really quick. This particular one I just pulled up here is not necessarily arbitrary. If we look for it in the central repository online, we can just copy that code and paste it in here in our POM file. Our code is going to depend on this one, which let me fix that indentation so it looks a little bit better. We add in this dependency to say our code depends on that. If I just click one real quick. Apache. Okay, usually it's really quick and it will automatically type it when we do it this way. I was wanting to do this before the break, but it looks like the break's in a couple seconds away. Work out Apache. If I do that and just put in like Apache Commons, choose one of these, hit add. There we go. And it just throws it right into our, oh, there it is. Throws it right into our code, our build file. So it gives it the instructions that go include those things. So with Maven, if you need to import any libraries, back to a reference to Python, remember how we have to go install the libraries and we just put import. Then we'd have to put that in our manifest to make sure it's installed in the other machine when we go to put things, run things. Here we don't, I'll move this up here for consistency. Whoops. We don't change our installation of Java. We just tell it where to go get any dependencies we need, and then they are brought down just for our one project. So if you need to import libraries that aren't part of the default installation, we'll do that. This one right here, you will definitely need when we get to Spring Boot soon. Okay, I wanted to get that far before the break, and the computer wasn't cooperating. I don't know why that right click and add dependency isn't searching. Usually the search bar is really, really quick, so maybe Zoom's messing with it, or I might have messed some stuff up last time I did a factory reset. So I guess kind of a preview of the Java projects and how we would deal with the package management in Maven. We'll see more of that as the semester goes on because there's quite a bit there, and that's a boring part. That's what we usually have to write all of that part, and that's where the build instructions come from. That's the instructions on how to put all the pieces together at the end. Okay, I assume the silence means no questions about arrays. 10-minute break sound good? See big head nods in here. And then after the break, let's look at lists. Because lists are much easier to work with in dynamic size. Once we have 5 elements. Or if we say we have 4 elements and then find out later we need 5, we just add 5th element in there. So more dynamic in size. So my laptop says 716. We'll get back to it at 726. See you all in just a moment.